So in this video you will learn how Kafka works at a very high level and you will get an overview of a Kafka cluster. At the end of this video you will learn how a Kafka cluster looks like, what a message is and what its structure, what a topic is, how Kafka handles scalability and what the partitioning is. Also, you will learn the relationship between topics and partitions. As we will see, it's a crucial concept. Finally, we will take a quick look at the main components of Kafka. So let's move on. Okay, this is a picture of a Kafka cluster seen at a very high level. It's a Kafka cluster including producers and consumers. Producers and consumers are the clients, the brokers in the middle are the servers. So producers are the source of data, consumers are the components that process the data, and in between we have the Kafka cluster. The brokers are what make up a Kafka cluster. They are essentially the main components of the messaging system. So the broker is a server that can be on bare metal, on virtual machines, on cloud, and even on a Raspberry Pi in theory. So the broker is an instance of a Kafka server process and it basically stores and organizes data. Okay, so the Kafka brokers store the data that comes from the producers, and the basic unit of data transfer in Kafka is the message. So the message is sometimes called a record, and it's basically one unit of data that the producers send, the brokers can store on disk, and the consumers read. So a message is fundamentally a key-value pair, and Kafka stores all the data as a byte arrays. That means we need to serialize data to byte arrays when writing data into topics. And we need to deserialize data from byte arrays when we consume data from topics. So it's important to know that keys and values are both unstructured and untyped inside the cluster itself. But from the point of view of producer and consumer, from the client applications, if they use a typed language, keys and values can have a type. So in general, the producers serialize the data from the data type used by the client into byte arrays, and the consumers deserialize the byte into data types used by the client. Inside the Kafka cluster, messages are organized into topics. Topics are named queues, named pipes of messages. There is an analogy to the database tables, but remember that Kafka is not a relation database. So Kafka uses topics to organize and categorize messages into ordered groups. The developer can decide which topics exist. By default, a topic is auto-created when it's first used. By default, Kafka auto-creates a topic whenever a client attempts to produce, to consume, or to fetch metadata from a topic that does not exist. You may need to change this behavior in production, for example, by disabling the auto-create topics property on the server. There are no limitations in terms of how many producers can write to a topic or how many consumers can read from a given topic. So there is no one-to-one relationship. Many producers can write to a topic, many consumers can read from a topic. But there are some implications to keep in mind that we will see in the next videos. Also, there is no fixed limitation regarding the number of topics you can create except the system resources of the server. Kafka is designed to be fast and scalable. It's not assumed that one only broker can completely handle a topic. That's for three main reasons. Number one, if the broker may fail, that topic will be gone. Number two, it may be too much data in the topic and it may fill the disk. And number three, it may be that too many producers or consumers and one machine cannot handle the I/O because the clients may overload the server. So the solution adopted by Kafka to solve these problems is the partitioning. Apache Kafka uses partitions to increase throughput and spread the load of messages to all brokers composing the cluster. So being a bit more technical, Kafka divides the topic into partitions, and each partition contains a subset of messages in an unchangeable sequence. In fact, the data in the topics is unchangeable. When you create a topic, you have to specify the number of partitions of that topic. You have to specify also a few other parameters, like the replication factor, but we'll see that in the next videos. The number of partitions identifies the maximum parallelism we can achieve with that topic, and the keys can be used for partitioning your data. When the producer sends messages into a topic, it uses an algorithm to make a decision about which partition to send it to. By default, it attaches the key of the message to a partition. But that can be replaced at producer level by developing a custom partitioning class if you want to partition the data, for example, using a different algorithm. As we can see, the partitioning is a very important concept, and it's what in Kafka does the message ordering. So in terms of main components in Kafka, we have consumers, producers, brokers, and Zookeeper. Apache Zookeeper is a distributed coordination service used in the Kafka cluster to mainly keep track of the status of the Kafka cluster, topics, partitions. We will go through each of these components individually in more details in the next videos. Thanks for watching this video. I hope it was helpful, and if it was, don't forget to like it. Subscribe to my channel for more videos like this. Thank you and see you in the next video.